Hello, everyone. Welcome to today's live broadcast, Challenges of Natural Preservative Application. I am Judy O'Rourke of LabRoots, and I'll be your moderator for today's event. LabRoots.com is the leading scientific social networking site, and we are proud to bring you this interactive web seminar. For more information, visit us at LabRoots.com. Here's how this presentation works. We want to hear from you. Questions, comments, and even answers can be submitted via the green Q&A button at the lower left of your screen. We'll try to get to everyone, but if not, we'll make sure to follow up with you by email. You can enlarge the slide window by clicking on the screen icon in the lower right-hand corner of the slide window. If you can't hear or see this presentation properly, let us know by clicking on the support button at the top right or the Q&A button in the lower left. I would now like to introduce today's speaker, Dr. Philip Geis. Dr. Geis joined the Procter & Gamble company, P&G, in 1981 as divisional microbiologist for product quality, disinfectant development, and study of household and skin microbial ecologies. His subsequent work as scientist and manager focused on preservation, method development, design, and operation of sanitary manufacturing systems and microbial ecologies associated with underarm odor, dandruff, toilet soils, and bathroom mildew. Through his career, Dr. Geis managed microbiology efforts for cosmetics, over-the-counter drugs, household products, and beverage and food business units of P&G. He also carried hard surface cleaner technical brand management responsibilities and is co-inventor for a number of domestic and international patents. In addition, Dr. Geis managed federal and state regulatory and environmental affairs. In 2011, Phil retired from P&G and founded Geis Microbiological Quality in affiliation with Biological Sciences and Advisory Services of the Advanced Testing Laboratory of Cincinnati, Ohio. He is an international consultant for microbiological quality of OTC drug, cosmetic, household, and industrial products and cultural properties. He's also an instructor for the Microbiology and Cell Science Department of the University of Florida. I will now turn it over to Dr. Geis.
Thanks very much. Thank you. I'm going to talk about natural preservatives and give you some practical perspective. I've worked in this field for a long time, and this is an area that, as I'll explain to you, has become very interesting, very important to the growing market. My talk today is going to be directed at fairly small, medium, and large manufacturers, not so much to the do-it-yourselfers and not so much to those crafters who sell their stuff at various fairs. I'm looking more to those guys who are going to have high output, large volume production and bring the issues they need to worry about, they need to be concerned with when they look at natural preservatives. I'll talk about is first why and what's the market, what is the need for natural preservatives and how big a market is it? I'll talk about what is natural, the basis for the claim, and the materials and identities, and both the identities and concerns. I'll go through a number of materials. It's not an exhaustive list. I put it together mainly to show you what's out there, what are the major elements out there, and what you have to watch out for in each, because these are not direct plugins for the current synthetics. Now I'll go through these comparisons and explain why these aren't plugins. There's a number of issues, number of considerations you have to make. And lastly, I'll give you an overview, sort of due diligence as you pursue natural preservatives. Though I won't discuss them, there's a long list of references you will be able to access at the end of this talk that may be useful to you. They're all technical references. It may surprise some of you, but there is a fair scientific literature base for preservation and related events. So why? What's the big deal with natural preservatives? Well, there's a number of factors that is driving this part of the market. In a sense, there's a lot of anti-chemical and poor science that's driving it. There's various NGOs or non-governmental organizations that have expressed great concern for current synthetic preservatives. There's a lot of bloggers out there that repeat this information, and they're on all sides of the political fence. The natural is safe and moral. There's true believers, herbalists especially, and some DIYs and crafters see the synthetic preservatives as very inappropriate. And there's science, and the industry has criticized this science, especially that of Philippa Darby out of the University of Reading in the UK, that questions the safety of current preservatives. Here's an example of the anti-chemical true believers. This is out of a very recent, otherwise pretty good article entitled Herbal Cosmetics and Cosmeceuticals. I encourage you to read it, not for this statement, not for the bias of the author, but more so for the range of information they talk about in there. But I'll direct your attention to this quote. This is taken directly from the paper. It's unqualified. It says, compared to other beauty products, natural cosmetics are safe to use. They're hypoallergenic and tested and proven by dermatologists to be safe to use anytime and anywhere. This is unsupported by any reference. It's a standalone statement. On its face, it's obviously incorrect. There's no way that every herbal cosmetic in the world has been tested by a dermatologist. And saying anything is safe to use anytime, anywhere is probably not accurate. But all the motivation aside, there is a growing market for this kind of product, for the natural products, especially the naturally preserved products. Here are some statements, and these are some old ones. So 2010 doesn't seem that old, but these were when the market was still growing, and the information here is there's a growing market for these places, for the ultra natural brands, and it was expected to account for about 17.4% of the industry by 2013, up from 5% in 2010. So how did that fare? Well, let's go to more recent stuff. The Klein and Company survey, and this Klein and Company is a commercial concern that does market research. It's probably the gold standard of market research. In 2014, they saw a 7% sales growth for natural cosmetics with natural preservatives versus 2% for the overall segment of cosmetics. Transparency Marketing estimates that it'll be a $13 billion market by 2018. And that's why we're seeing some major retailers questioning the use of the traditional synthetic preservatives. But so what is natural? Does the FTC give us a definition of natural? Well, it doesn't. It doesn't define natural at all. What it says is, if a reasonable consumer could interpret a natural claim as representing that a product contains no artificial ingredients, then you have to be able to prove it. And be clear here, that proof has to come from the guy that's marketing it, not from your supplier. If your supplier says it's natural, and you take his word for it, you may be in trouble. You're the one that's responsible to make all to prove it in question. In Europe, it's a bit more prescriptive. I offer the definition here from the Council of Europe. Their guidelines specify that it has to be obtained by physical methods, extrusion or filtration, or microbiological and enzymatic methods only. So you're a bit more constrained in Europe. In the US, you have to prove it, but it doesn't say how you have to prove it. But in both cases, if you're challenged, if you, the market, is challenged, you are responsible to prove it, not the supplier and not anybody else. So let's just get into this. Before we do, though, I want to emphasize one important element. The preservatives are very important, probably the most important ingredient in a cosmetic, or even in an OTC cosmetic in many cases. The reason is it is the sole ingredient added exclusively for a safety purpose. Even the guys that use synthetic preservatives, and those are still the major part of the preservatives that are used in cosmetics. They don't use them because they want to. They're expensive molecules. They get a lot of flack. But they use them because they feel they have to, because they serve an affirmative risk assessment. Preservatives serve a confirmed risk assessment that the manufacturer can say this product is safe to use. It's not a matter of putting in a preservative and saying, I've got a preservative in there, it'll probably work. It's an affirmative thing. You have to be able to prove it if questioned. And the consequences are really serious. And certainly there's regulatory action, and nobody wants a recall. But there are clear cases of infection that have come from cosmetics that have caused blindness and even death. That sounds very serious, but here's one I've culled out of the literature, a fairly recent one. This is an issue that developed in Saudi Arabia, and this is not uncommon for the third world. This is a product that is a knockoff of a very famous domestic shampoo for babies, and I won't name it. But this is a knockoff. They knocked it off, they reproduced it in their own factory and sold it. Unfortunately, it became contaminated with bacteria, with a bacterium called Serratia marcescens. It sickened 3 of these babies, and one of them actually died from the infection. And this is consistent with what happens with contaminated shampoos like this, or contaminated cosmetics in general. You have a sensitive population. Is typically the immunocompromised population. Here is the kids. Here's the babies. It could be folks with chronic diseases like diabetes or cystic fibrosis or AIDS. Folks on therapy to reduce their immune system, perhaps on cancer therapy or anti-rejection therapy, or on some of the new drugs that you've seen advertised for rheumatoid arthritis or even psoriasis on TV. The estimate currently is that there's over 25% of the United States population is considered immunocompromised, and especially sensitive to this kind of contamination. So this is not a trivial matter. This preservative is a very important ingredient. It's probably the most important ingredient in any cosmetic. So what are we going to talk about? We're going to talk about natural preservatives. So I'm going to give you a test, and it's obviously a take-home test because I can't grade you on it. I want you to look at these molecules here, these materials, and decide which one of these occurs naturally. I'll give you a couple of seconds here. Just go down there and say, which of occurs naturally? Just for information, the isothiazolones are synthetic chemicals. There's a quick answer. That are found probably in most of the shampoos and surfactant products like body washes and hand wash products in the world. They're one of the most common preservatives. If you had a chance to look at it, here's the answer. These are the ones in red are the ones that don't occur naturally. Methylparabens, it can be found in flowers, berries, and bacteria. Formaldehyde, it's a common biological molecule, again, at very low levels. Grapefruit seed extract, the darling of so many bloggers, is not natural. Even as supplied, it's not natural. It's a chemical derivative of a natural material. Now, the isothiazolones, of course, are not natural. They're a very common synthetic preservative. Tea tree oil, benzoic acid, thymol, and eucalyptol are indeed naturally occurring materials. The next question I'm going to ask you is, which of these in its primary commercial supply is natural? And you see it's only tea tree oil. Of course, methylparabens, as used commercially, is synthetic chemicals. Same with formaldehyde. I've mentioned grapefruit seed extract as being not natural as a chemical derivative. And even at that, it probably isn't even an honest preservative, to use a term. There are a number of papers, maybe 8 from around the world, including one from the United States by the USDA, that report that grapefruit extract is adulterated with various synthetic molecules, synthetic biocides, like parabens, like triclosan, like various quaternary ammonium compounds used as disinfectants. And in primary commercial supply, benzoic acid, even thymol and eucalyptol are synthesized. It is easier and cheaper to make them synthetically. To make exactly the same chemical synthetically. But we're not talking about synthetics. We're going to talk about natural preservatives. And I'm an editor of a journal that talks about biodegradation. And I'm getting a lot of articles that talk about natural preservatives. And if I went through the list, these are the ones you might find. Honey, salt, and water removal, or low water activity. The botanicals, alcohol, organic acids, chelators, enzyme systems, and what you call antibiotics, or things that inhibit bacteria that are obtained from other bacteria or other organisms. I'm not going to talk about honey, salt, and water removal too much, especially honey and salt. Those are not practical for cosmetics at all. So here, the natural preservatives, one of the biggest things people talk about are botanical, things of botanical origin. And here's just a list of some of the plants from which people have said we've gotten materials that are effective as preservatives. I've put grapefruit seed extract in there as a highlight because, again, that's a very questionable material. But there's a number of other ones, and you can see them here. And you could probably, if you're familiar with the industry, you probably know some of these things yourself. One of it is the botanical oils, the essential, so-called essential oils, and these are typically obtained by some kind of this hydro or steam distillation. You can also obtain it by extracts with organic solvents like ethanol or hexane, or even supercritical fluid extraction with CO2. By each of these different extraction methods, or the hydrodistillation, you get a different set of chemicals. And that's important too, because the botanical extracts can vary considerably based on the way they're obtained. What you saw as hydrodistillation would give you one set of chemicals. If you extract it with ethanol or use CO2, critical point extraction, you get another different set of chemicals. So the extract that you use, you must make sure you have a consistent supply in terms of the way it's obtained, so you have a consistent supply, a combination of chemicals to give you the right activity. So but these are not magic. Botanical extracts, whatever they are, whether they're essential oils or whatever, these are not magic. They have chemicals in them, biologically oriented or originated chemicals, these various hydrocarbons and other chemicals that are responsible for the activity. And here are some of the major sets are terpenoids and aromatics and some others. I put in red some of the ones that I'm familiar with that have fairly good activity: the terpineol, the geraniol, the eucalyptol. And you'll recall eucalyptol can also be obtained in quantity by commercial sources, by synthetic sources. The aromatics like phenethyl alcohol, benzyl alcohol, eugenol, thymol, and others like menthol, aspen bark, which is really salicylic acid, and naticide. Now, phenethyl alcohol, people often ask me for replacements for various synthetic chemicals, and I mentioned phenethyl alcohol. Here's a petri dish, and you can see on the left side is Staph aureus. It's a gram-positive bacterium, and there's phenethyl alcohol in this agar. In fact, phenethyl alcohol is a commercial agar that's used to isolate gram-positive bacteria because it inhibits gram-negative bacteria. This Serratium arcescens on the right is the same microbe that contaminated that shampoo that unfortunately killed that kid in Saudi Arabia. But this is one of the ones that you might consider perhaps in replacing phenoxyethanol or some of the other chemicals that are used to inhibit and kill the gram-negative bacteria. Phenethyl alcohol does come with a fairly strong, not a strong odor, but a characteristic odor, sort of a rose odor. In fact, it's called rose ether in the commercial sense. So what about botanical? If you had to worry about them, if you had to use those things and you wanted to make sure your product was preserved correctly so you didn't kill the baby again, what would you be interested in? Well, the process variables. How was it obtained? Was it heat? What was the process? Was it a solvent? Because you want the same set of chemicals every time. And these things are all in the literature that you'll find at the end of this talk. The plant part, the different combinations, even though it may be rosemary, you may get a different set of chemicals if you extract the leaves or the stems or the roots. The developmental stage, young versus mature leaves gives you a different set of chemicals. The season of harvest and the region of cultivation. If you harvest it in the spring, you may get a different set of chemicals than you get in the fall, and that's been shown in the literature. The region of cultivation, you may have different biotypes of rosemary in different parts of the world. And there's different chemotypes of the product. And pre- and post-harvest control. Now, this is real important. Lots of reports are out there that indicate pre- and post-harvest control is not adequate. Pre-harvest control means the use of pesticides. And these pesticides are in the plants and will be extracted with the essential oils. So you have to make sure that you don't have pesticides coming in with the product. And the same thing with something called aflatoxin. It's produced by fungi. It's a fairly effective carcinogen at higher levels. And at real high levels, it'll knock out your liver and knock out your kidneys. It's in all the grains that you eat, in peanuts and peanut butter constantly. But you don't want it in your cosmetics. And again, the presence of synthetics, as you probably have heard with grapefruit seed extract. So how would you do this? This has always been an issue that I've found. Talking to some of the folks that supply essential oils, I've said, I'd really like to have fine chemical analysis that shows consistency from batch to batch, because I'll make this product for years, hopefully, and sell it to a lot of people. I want to make sure that preservative works every time. And I've talked to various herbalists, and I understand their viewpoint, but it doesn't serve my purpose. What I've often heard is, well, Phil, I know about these herbs. I know when they're good. I know when they're contaminated. I know what the composition is because I'm an herbalist. I've been doing this my whole life. I can smell it. I know by the feel that this is good stuff. And that may work for them, but it doesn't work for me because I work in a business where I have to answer the FDA if my preservative goes south. And I have to answer to my management and ultimately to my customers and their parents if the preservative doesn't work and it hurts their kids or hurts one of their loved ones. So what else about commercial botanical extracts? Well, they're pretty costly. They have product effects. They usually carry odors, often color and texture, and they have chemicals that affect the stability of the product. I mentioned too that the phenethyl alcohol smells kind of like rose. It's called rose ether. And indeed, that may be something you don't want to have in your product. The rose isn't bad, but that may not be the smell or the odor you're trying to impart to the product. So composition is variable, and supplier information isn't always great. What you really want to know is enough data, maybe some GC data, that tells you if the actives are there, the ones that maybe I hadn't read, and that they're at a certain level. And you want to make sure the impurities of concern are not there, the potential adulterants. You want to make sure mycotoxin is not there and pesticides are not there. And these are very justifiable requests, and you should make these requests and get these data if you're using the commercial botanical extracts. So let's move on to the alcohols. You guys are familiar with ethyl alcohol, certainly. Benzyl alcohol is a fairly good preservative. It also can be found in a natural source. And as I mentioned, phenethyl alcohol. You've got to have a lot of ethanol as a standalone preservative. We typically look at about 20% is the critical cutoff point. We have some effect down to 5%. So ethanol can be combined with other preservatives and maybe give you an effect down to as low as 5%. Less than 5%, you're not going to get much of an effect. Benzyl and phenethyl are pretty good. Their use levels are typically less than 1%. Their primary efficacy is against gram-negative bacteria. So you might not be so good against some of the gram-positives. These are bacteria like Staph aureus. But they have cost. And as I said, the phenethyl alcohol has odor, and benzyl has a little bit of an odor too. Let's talk about organic acids. This is also a fairly common source of preservatives that people consider for natural products. I'm made a list here, but the ones I put in red are probably the ones that are more active. Sorbic, benzoic, salicylic. You usually add these as soluble salts, sodium or potassium salts. The reason for that is the acids are not soluble at the typical pHs where you have to add them. So you take forever mixing it to get them to go in a solution. And the costs from a natural source are a lot greater than the costs from synthetic sources. They have limited efficacy. The contamination risks you face in industry are anywhere from about 3, but it's fairly acidic, to 11, which is fairly basic. The organic acid efficacy is at best below 5.5 and typically below 4.5. So anything out that's not fairly acidic is not going to get much benefit from organic acids. And what they do affect is they affect fungi, yeast, molds, some bacteria like Staph aureus, but not Pseudomonas, not gram-negative so much. I mentioned before that those organic alcohols affect gram-negatives. Well, these affect the other bacteria, the fungi and some bacteria. Typically, these things have limited usefulness, so we use them with additional preservatives. And they, too, can have product effects. Color, pH changes, because you want to have it low, and solubility, if you aren't able to get it to go into solution. So remember, you always use the salt of these acids. Let's talk about some chelators. You may have noticed that a lot of commercial cosmetics use EDTA. It's ethylene diamine tetraacetic acid. It's not a preservative on its own, but what it does, it has a big affinity or a love for calcium and magnesium and iron, and it makes other preservatives work better. The idea is that the EDTA especially takes the magnesium out of the cell wall of the bacterium, and that cell wall is less stable, so the preservative can get in there. It also gathers up the iron, and all of these, many of these bacteria and all these fungi require iron for their to be able to breathe. Their cytochromes. So if their iron is gathered up and stopped, they can't breathe very well. So you might consider these things as replacements for EDTA that help preservatives work better. They're not primary preservatives. Hinokitol, some of you may be familiar with that. I've had receipts of that have come in contaminated with bacteria itself, so you have to be aware of that as well. And again, as with a lot of these things, the complexes may be pigmented or colored. Let's talk about some antibiotics. I'll try not to mention some of the ones you may be familiar with because I'm not talking brand names. But some of the ones used in foods are nisin, natamycin, and there's one that's being used a lot now and talked about a lot in the natural preservative area is a peptide from radish and kimchi fermentation. Nisin, natamycin are GRAS for foods, which means generally recognized as safe, which is good, of course. These things have limited efficacy, especially versus gram-negative bacteria, which is, again, the same kind of bacterium that killed the kid in Saudi Arabia. The solubility can be pretty limited. The levels needed are fairly high, and these are not inexpensive, so these are fairly expensive preservatives. There is an adulteration concern with the last one, the peptide from radish and kimchi ferment. It's a single article. The supplier of this material claims it was published at the request of a competitor, but it was from the university, so that question is still open. It hasn't been confirmed yet in any kind of literature. Let's talk about one enzyme-based. This is sort of equivocal as a natural. Certainly the enzyme is natural. Some of the chemicals you have to add to make the enzyme work are not natural, but they're at very low levels. This is available commercially from Arch Chemicals. The cascade is initiated by the action of glucose oxidase, and it goes through a series of reactions to generate an antimicrobial component. It has a very narrow pH range, 4 to 6. You can find this in some of the natural brand shampoos especially. And it loses substrate over time, it loses activity over time, and with any dilution, it'll lose efficacy. The idea is that when you open the bottle, you let oxygen in, it starts the reaction, and it produces some of the antimicrobial component that knocks out the bugs. You close the bottle, and it doesn't, and the rest of it is not exhausted. So it has a relatively limited shelf life. And if you dilute it, you're going to probably get bugs in there, and they'll grow on the glucose. Usually on the glucose. It's an interesting preservative. It is used commercially by some of the brands. So here's the ones I've talked about. The botanicals, especially the extracts and oils, organic acids, glucose oxidase, biological chelators, and antibiotics. In my experience, I'd use none of these by themselves. I'd use them together. And there's something called the hurdle concept, which envisions the idea that you're setting up a bunch of hurdles for the bacteria to jump over to contaminate your product. You can't hit them with a baseball bat right off the bat like you can with the current synthetics, because the botanicals, these other things just aren't that strong. So you set up a whole bunch of them, so the bacteria jumping over these hurdles gets worn out and doesn't survive. And one element you might consider, and I put a picture here on the right side, is packaging. Packaging will help you preserve a product. It's the ultimate preservative, because if you could make a unit dose, you probably wouldn't need preservatives. But what it does is lower the amount of bacteria and fungi that can get inside your product and challenge it and make a mess of it. So what do we know about natural preservatives? I'll talk about is the various subjects: efficacy, safety, regulatory affairs, in the context of each of these materials. But first, let's compare it to the equity of traditional preservatives. So these are the parabens, the isothiazoles, the formaldehyde releasers, EDTA, the things that have been around for probably the last 50 to almost 100 years. The composition and purity is well known. These are synthetic chemicals. They're consistent. They're made in plants. You know exactly what the impurities are. You know exactly what the consistency is. They're made to specification. You know their concentration. We know they're stable. Direct and indirect on the formula. We've had decades of working with these. We know their stability in emulsions and their effect on products. Typically, the industry at large looks for a 3-year stability date, and that's my experience as well. We look to bring stability to preservatives, so it's effective through 3 years of consumer use. Actually, 3 years from making. And process. These things, as I said before, I'm not interested so much in what's going on in the crafters or the hands of the DIY folks, but the folks that are manufacturing in bulk. And when you make a cosmetic, you often have transient effects of adding different ingredients. So you have heat and some ingredient combinations. And there's transient effects of acid and base. So you know with these traditionals, you know where to add it. It's not a mystery. You add certain things when it's cool and certain things when it's hot. And you know where to add. There's so much experience behind this. And validation. This is an important element, and it's one that is difficult for a lot of folks to understand. The major manufacturers have all done consumer use to validate that a preservative system developed and tested and proven to be effective in the laboratory by their testing is also effective in the hands of the consumer. So they might put thousands of units out, let consumers use them for the regular period of time, and get them all back and look for bacteria. And that's how they validate their test. But there's also validation in manufacturing. It's sort of an effective one because you can't do the same thing you did for consumers. But if you can make a system that passes your preservative test over and over and over again for year after year in your manufacturing facility, that's effective validation. You say, well, I've got to have preservative in manufacturing because I'm not making it in sterile conditions. And I've made it all these years after it passed my test, so I think it pretty much validates. And then the last element is important, again, for the guys that are manufacturing and marketing in bulk. There's minimal and consistent impact on product development cycle. And what that means is when you innovate, when you bring out new products, it takes a lot of time sometimes to make sure a new preservative, the one you have no experience with, is safe and effective. But one you've used for years and years, like the parabens, like the isothiazoles, like the formaldehyde releasers, you know the bumps, you know the weak points. And you can be pretty sure that it'll pass all the tests so you can have everything going as rapidly as possible, bringing new products to market. So let's compare this to the natural preservatives. The composition and purity. Now, the record here is limited to none. You're going to have to discover this yourself when you're with your natural preservative source. You're not going to have Dow Chemical or Monsanto providing these natural preservatives. You're going to have much smaller guys who may not have the chemical capability of telling you what's in there. And so you have to find a way to get the composition and purity that you need to know, one, to make sure it works, and two, to make sure you're not bringing anything bad that might hurt your consumer. Stability. As I said, we have 3 years in our products and the synthetic products to demonstrate preservative stability. Again, for your natural preservatives, you're going to have to do this case by case. And this, you're going to do it by every formula. And because formulas may change, and you won't know because you have no experience with it, how a changed formula is going to be affected by the preservative, or vice versa. You may have heard of period after open, PAO. This is not I want to emphasize, this is not a get-out-of-jail-free card. And I've encountered some companies that have seen it as such. They've had natural preservatives that haven't been stable. So what they did was, if it was stable only for 3 months, they put their PAO at 3 months. And I want you to think about that because there's two major flaws here. One is the PAO doesn't tell the consumer a whole lot because that product might have been made 6 months beforehand or even a year beforehand before it got to the consumer. So it's for stable for 3 months. You can't presume that it's going to be, that clock starts when the consumer opens that bottle. And more importantly, all the literature, and there is published literature on this, and you'll find that in the references at the end, say that consumers don't care about things like this. They don't look at dates like PAO or expiration date. They use it when they want to use it, and they use it as they want to use it. And lastly, time is not the element. I know many of you have heard that mascara shouldn't be used more than 6 months. Well, in my experience, the preservative is stable in mascaras for the typical period of 3 years. 6 months, the preservative is still there working. Mascaras are contaminated not by time, but by the consumer use pattern. By people spitting in the mascara, licking or spitting on the wand, or doing other things that adulterate the product, leaving it in the car too long to get it hot. Not by time. Time is not an element here. For process, you got to figure out where you're going to add this natural preservative. Is it stable if you add it in the hot mix? You have to add it cold. If you add it cold, will it go in a solution well enough? And efficacy. This is the ability to preserve the product. This is case by case. The potential for contamination is going to be greater here. So you may have to have greater manufacturing controls than you had before. Because you made it with things that you knew were going to, like the baseball bat, we're going to knock down the bugs. Here you may have a series of steps to knock down the bugs. And will your current manufacturing controls be enough to protect the product? And lastly, consumer protection. Again, you know that those synthetics for the baseball bat work really well to protect consumers. Is this hurdle product going to protect consumers? In all honesty, you guys should really probably do some consumer use studies because that's what a lot of folks are doing now in the major cosmetic marketing world as they try to understand whether they can use natural preservatives or alternatives. And of course, efficiency. The impact on product development cycle is going to be very significant because with your parabens and your formaldehyde releases may have been a great preservative, so much so that you can count on it working every time. So you could do some rapid testing to make sure it appeared to be consistent, do some chemical analysis on on the actives to make sure they were still there and go right to market, and then go back and develop a new innovative product. For natural preservatives, you're going to have to do a lot more work to make sure it works. And that work means time and money. It's going to take more time to do it. It's going to impact your product development cycle, so you're going to be less efficient, and you're going to take longer to bring new products to market. Compliance. This is a tough one because there's a lot of different approaches here. For natural preservatives, comparing it to the current synthetics, there's a big difference. In the U.S., as you probably know, the responsibility is in the marketer for safety. He's responsible for the safety of the preservative and everything in the product. If he hasn't shown it safe, he has to say so on the label. Well, in the U.S., we have the Cosmetic Ingredient Review. We have a lot of research behind the current synthetics that say they're safe in use. In Europe and most of the rest of the world, there are positive lists. You can use preservatives that are on this list. You use Cosmetic Directive as one of them. You can't use preservatives that aren't on the list. And so basically there's a set of maybe 5 or 6, maybe 7 or 8 synthetic preservatives that are used consistently throughout the world. These are the ones that work, and no new preservatives are coming to market. And that's why the current marketers are so concerned, because nobody's bringing new preservatives to market. And these synthetics are disappearing, or people want them to disappear. Let's compare that to natural preservatives. Again, in the U.S., you can use what you want to, but you're responsible for the safety of the product and the safety of that preservative. And if somebody asks you for the data, you need to have those data. It's not enough to say my supplier said it was safe. You need to have data that says it's safe. On these positive lists, every place else but the U.S., you're not going to find many of these listed, especially the botanicals. And you're going to have to decide how you will comply. I've seen some folks say preservatives are the secondary benefit. They really wanted to include these things because they're perfume actives or they serve other functions. I've seen one term called microbial blocking technology, which tried to, I believe, finesse the positive list. But again, if you don't have, if these are on the positive list and you're using as preservatives, theoretically you're not in compliance with the rest of the world other than the U.S. And as I said, please don't count on the PAO to cover a lack of stability. Here's a citation to that article I was talking about. These guys looked at expired makeup, including mascara, to see if people actually followed through if they put expiration dates on it, and they didn't. People did what they did before there was any expiration date. They didn't read it, they didn't care. So you're responsible, I said, to your consumers for all these items for the natural preservatives. And there are some other elements that have come out that we've seen. The recalls of contaminated products are very, very serious economically. They're more serious because you might be putting your consumers at risk, and I know that's what you guys are worried about. But the government is also concerned. They want to protect their citizens. And they'll find, certainly the FDA and the RAPEX recall out of Europe are well-known recall vehicles. But in every country in the world is a recall vehicle. The natural preservatives are what is being recalled now. And though very few recalls are happening in the U.S. because most of the market is still with synthetics, those few recalls they'll find are associated with natural or alternative preservatives. Unfortunately, in Europe, there's a lot of recalls, and almost all of them are associated with natural products. A recent review by these authors here, recalls of microbiological contaminated products, and this was just 2008, and it's gotten worse since then. They went through all these recalls, and they said, it looks like all these products are natural products, including some organic compounds. And what they theorized was, it's not just the fact that it has a natural preservative, but because they're combined with other natural ingredients, and these natural ingredients all bring in a bioburden. And the normal way of making products, that's just the normal, the classic way, you have chemical ingredients you combine. These chemical ingredients don't have a bioburden. They don't bring in bacteria. For the natural products, with the somewhat weaker natural preservative, you bring in natural materials. And these natural materials often have a lot of bacteria in them that put a greater burden on the product than they would have had otherwise. So a lot of these recalls are associated with natural products. Again, these fall back on the items of knowing what your active is in that natural material, making sure it's at that quantity, controlling your manufacturing. In this case, you have to make sure your raw materials are really clean. Don't bring in bacteria too. So the three elements, your manufacturing controls, your preservation, and your packaging, all have to be modified if you're going to use natural preservatives. So compliance. I think we just said that. Sorry, I'm going to jump to this next slide. So what is it? Let's talk about safety. The equity of current synthetics, extensive database. These have been around for a long time. They've been reviewed by the CIR, regulatory bodies. They've been looked at all sorts of ways. And the FDA has no issues with the current equity, the current synthetic preservatives. The safety issues identified are largely based on data and experiment models irrelevant to use or just poor science. You may, if you search the labs, you'd find just innumerable references citing parabens cause breast cancer. That's totally bogus, totally false. So what do you have in naturals? Again, they're perceived as safe. Why? Because they're natural. But the data may be, in fact, usually is very limited. You may have contamination, as I said, with botanicals, the pesticides, the mycotoxins, even microorganisms. There's sensitizers, cinnamaldehyde enzymes can be sensitizers. And the issues really, when you get into it, are similar to what are alleged for synthetics. Here are just a couple of references that are again in the citations at the end. The mutagenicity effectively of rosemary oil on mammalian cells in vivo. This is the kind of stuff that has been used to criticize synthetic preservatives. Habituation to sublethal concentrations of tea tree oil reduces susceptibility to antibiotics. So this article suggests that the more you use tea tree oil, the more you're going to have bacteria resistant to antibiotics. And the last one here, prepubertal gynecomastia linked to lavender and tea tree oil. These were young boys that were using palm oil or using a pomade on their hair that had high amounts of lavender and tea tree oil, and it caused them to grow breasts. That's what the article quotes. So the concept that natural means safe is pretty questionable. It sounds good, but it's not supported by the data at all. Other factors, well, synthetic preservatives, as I said, the product effects, we know those well. We accommodate these in our product development cycle, and the environment impact of production is regulated. These are chemical plants like Dow and Monsanto. And they're compliant with EPA emissions standards, both air emissions and water emissions. They know what comes out. They control that. Natural preservatives, yes, significant product effects. As I said, a unique developmental cycle and unknown environmental effects. Some of the plants that people plant in other areas in a commercial sense to produce these essential oils or other botanicals are actually invasive in other parts of the world. So you have to know the environmental effect of your supplier. In fact, there's a surprising, that may surprise some of you, concern associated, it's been voiced by the UN regarding some of the botanical products. As they say here, in very poor communities or unreliable environments, the consequences of such risks, and the risks here are shifting from food, because they're talking about subsistence people, subsistence farming, folks in poor third world countries who are shifting from food production for their families to herb or essential oil production because they think it's a big cash crop. And the UN says it may be disastrous because people plunge. And so they've seen localities plunge into the production of essential oils or herbs, and if the market crashes, if they can't sell it, they're left without food because if their risky cash crop fails to generate income. Now, I want you to think about that. Think about Nike and its sweatshops. If you were a company, would you want to be associated with this kind of disaster? And indeed, I'm sure there are organizations that would discover that were the case. Let me give you an overview. I'm going to wrap it up here, but I want to emphasize that you have a due diligence if you're going to use natural preservatives. It's a growing market, and people will take advantage of it. Tens of billions of dollars is the market people need. You've got to control your preservative quality, and you must insist on analytical specification, even for your botanicals. I know that the herbalists and their honest folks will tell you that it's consistent, but what you want are certain chemicals that impart to that to impart to that the activity you need. So you need to make sure those are in every batch you receive and the level that's going to be effective. Safety assessments. Again, this is your job. You need to know to have the impurities, and you'll probably need to get increasing amounts of data as you go on. The microbiological risk assessment. The most important thing, remember, this is the only ingredient added exclusively for a safety purpose. You're going to have decreased efficacy versus synthetic, so you can't just plug it into an old formula, a formula that you made for a long time with synthetic, and say it'll work. It's going to be an atypical product, so you'll probably have to have a hurdle concept, hurdle of preservation, and that may mean higher manufacturing controls. It probably will, and more consumer protection in terms of packaging. So again, it's not a simple plug-in in what you had before. You need to be aware of potential compliance and PR issues, and public relations issues. Again, the positive list in the rest of the world, except for the U.S., is very limited. It lists a lot of preservatives, very few of which are actually used because very few actually work. And very few of those are botanicals. And lastly, safety, environmental, and social issues are yours. Not just the claim that it's natural. That is your responsibility as well. But the safety, the environmental impact, and the social impact are all going to come back to the people that are using it, the deepest product. Just like it did for Nike. So all these things are things that I beg you to consider as your due diligence in this growing market. This market will be populated by people. It's going to make a lot of money for a lot of folks. And it's getting bigger all the time. As you may know, some of the major retailers are pushing on some of the big cosmetic manufacturers to move away from some of the classic preservatives. And natural preservatives would seem like a good place to go because there is a growing market for that. But it's one that has some real traps in it. And remember, I'll leave you with a final thought that the preservative is the only ingredient and exclusively for a safety purpose. And that's what you need to be aware of, along with all these other things. And you'll see the references are right here. I won't go through all the pages. There's maybe 10 pages that talk about natural preservatives, talk about the safety of them, the sourcing of them, some of the watch-outs that I mentioned. And I'd be happy to take any questions.
Thank you for that presentation, Dr. Geis. We want to get right to your questions and input. So here's a reminder how to let us know what you have to say. Questions, etc., can be submitted via the Q&A button at the lower left. We will try to get to all of you, but if not, we will be sure to follow up after the broadcast. Let's see, first question is coming in. So our first question is from Lilia at MSU, and she asks, can the preservatives from the animal sources be considered as well?
But I'm sure you can make a good case for it. I'm not aware of that, but I'm sure you can make a good case for animal source preservatives. There is a concern, though. You should know that in many cases, in many countries, there's concern for BSE, which is bovine spongiform encephalitis. So much of the cosmetic industry stopped using animal-derived materials, especially things like tallow, because they were worried about passing on that disease.
Okay, our next question is from Ren at Eye-Open Outcomes, and the question is, are there sources of grapeseed extract oil that are quality controlled for contaminants, and what safety concerns about this derivative are known?
Article tested a whole bunch of, I think it was eight receipts of grapefruit seed extract oil, and they found that the only one that had no adulterants in it, no parabens, no triclosan, no benzethonium chloride, didn't work. So I really can't answer that because I'm not familiar with any grapefruit seed extract that actually works that isn't adulterated. And frankly, I would my personal preference is to avoid that material.
Okay, we have have a question from Lillian, and it is, considering allergic patients, how would you compare natural versus synthetic preservative in terms of control quality, safety, efficacy, side effects, and sustainability?
Preservatives have a known level of sensitization, a known level of provoking allergy in folks or allergenic reactions. That's well known. What's not known is that of the wide range of natural preservatives. But there are a lot of natural preservative components that are included in fragrance oils that are recognized as allergens in various regulatory documents, especially the EU and the Cosmetic Directive. So both of them can provoke allergenic responses. Both of them can certainly elicit response from those who have been sensitized. And the percentages are known for the synthetic preservatives, and not so well known for the natural preservatives. That too is again something that you'd have to answer for yourself. And some of that is actually included in the references that I provided.
If there are no more questions, I would like to once again thank Dr. Geis for his presentation. Do you have any final comments, Dr. Geis?
It doesn't seem to most folks that it's dangerous. That a preservative that doesn't work is very dangerous to folks. It's caused blindness because of infection of the persons from contaminated products. And as I pointed out, it caused the death of those children. And there's such a large percentage, surprising large percentage of the U.S. and the world that's immunocompromised. That is a major concern. So please, I appeal to you, whatever preservative you do use, make sure it works, because your customer is at risk if you don't.
I would like to thank our sponsor, LabRoots, for making today's educational webcast possible. LabRoots.com is the leading scientific social networking site. For more information, visit us at www.labroots.com. Today's webcast will be available for on-demand viewing on our website through February 2016. We will let you know when it's been posted, and we hope you pass this information on to any colleagues who couldn't take part in today's broadcast. See you next time. Goodbye.